This is the first in a series of videos on completing the square. We'll take a look at completing the square for monic polynomials first. And a monic polynomial is one with a lead coefficient, in this case the coefficient of x squared, equal to 1. Now the general idea is to take an expression like this and transform it in a particular way, and we'll show you how that works. Now first, we note the geometric interpretation. For the blue blocks, the first one on the left, the square, has sides equal to a length of x. So the area of that block is x squared. Each one of the thinner blocks next to it has a width of 1 and a height of x, whatever x is, so that each of those has an area of 1x. And you'll notice that there are 4 of them, corresponding to 4x in the original expression. And finally, there are the yellow blocks, each of which is 1 by 1, 1 unit by 1 unit, so each of those has an area of 1, for a total of 20. Now if you add up the x squared, the 4x, and the 20, that gives you something with an area that is represented by the expression. Now we're going to rearrange the pieces a little bit. First, we're going to take the 4x blocks, and as you see in the lower representation, we moved 2 of them to the right of the x squared and 2 of them below the x squared, and that creates that little square notch in the lower right hand corner. Now we're going to take 4 of the yellow blocks, because that's what fits, and we're going to fit them into that square. Now on the left part of the lower row, we have a square that has area x plus 2 by x plus 2, that's x plus 2 squared, and then we're left with 16 ones. The total area of the top line and the bottom line is the same, but the arrangement is different. Now in so doing, we've transformed the representation of x squared plus 4x plus 20 into x squared plus 4x plus 4, that's on the left, plus 16. And we can see very easily that that square is obviously a perfect square. The trinomial x squared plus 4x plus 4 is a perfect square. And that can be factored to x plus 2 squared plus 16. What you're looking at now is the result of completing the square. In other words, we want to take the expression x squared plus 4x plus 20 and transform it into the representation below, x plus 2 squared plus 16. Now, one of the skills that you need to develop is how to take a polynomial that has 2 terms and find that third term that makes the polynomial a perfect square. And we'll take a look back at our representation. Now if you look at the lower left, what we did was we had 4 x blocks and we split them in half. We took 2 to the right and 2 to the bottom. Here, if we look at n squared minus 24n plus blank, we can take the 24n and split it in half and put 12 to the right of the n squared block, 12 below the n squared block, and we'll ignore for a moment the fact that they're negative blocks. But you can see that if you do that, you will have a notch in the lower right that is 12 by 12. So what we've done is taken half of 24, which is 12, and then we square it to get that final constant term. And now we can factor x squared minus 24, or rather n squared minus 24n plus 144 into n minus 12 squared. And that's exactly what we want. Let's take a look at one more example. To the upper right, we have x squared plus 3x plus something. And in this case, we can take half of 3, which is 1 1/2, or 3 halves, 1.5, square that to get 2 1/4, or 2.25, and that is what completes the square. Now, this polynomial is factorable into x plus 1.5 squared. I'd like you to stop the video and see if you can complete the square on the 6 remaining polynomials. Pause the video for now, and we'll restart when we come back to it. Okay, I'll look at these first couple one by one, so that if in doing the third one, that gives you clues on how to complete the rest, you'll have a chance to stop the video again. So for the third one, we have y squared minus 13y plus something. We take half of 13, that's 6.5, square that to get 42.25, and then the factorization of y squared minus 13y plus 42 1/4 is y minus 6.5 squared. In the next one, we have x squared minus 32x plus something. Take half of 32 is 16. Square it is 256. And the factor is x minus 16 squared. For the next one, x squared plus 40x plus something. We take half of 40, that's 20. Square it, that would be 400. And now we have a perfect square trinomial, x squared plus 40x plus 400. And the factorization is x plus 20 squared. Next, we have a squared plus 11a plus blank. Half of 11 is 5.5. Square 5.5, and we get 30 1/4. And the factorization of that is a plus 5.5 squared. And I'll just show you the final two. And this completes our first look at completing the square.